Okay, guys, let's talk about the project here. First part of the project, we need to talk about what these kind of reports are going to look like. So let's take a look at that report file. Here's your prompt for the first part of the project. We're going to be looking for a document with a heading and a title. So your information, introductory paragraph, talking about what this calling it tutorial covers. And the reason I call it a tutorial is because I kind of give you step-by-step instructions, have you do some research on your own to figure out how to conduct and use this model and set it up. So you're going to want to do some screenshots at some pivotal steps and kind of describe the steps so that when you go back and look at this, if you ever need to use this model again, you'll have some basic information about how to do that. So we're going to start off with an introduction to the actual watershed. So I've given you a watershed outlet point, a coordinate. You go on StreamStats and you can download or create that watershed, delineate it, and then download information about it. You can also do this research on your own. So we want to know what's the drainage area, the elevation range, what's the land cover and geographic setting? Is this in the valley? Is it in the mountains? How steep is it? What's the general climate, do you think? What do you think, what kind of floods do you think would happen there? And then we'll talk about stream order. I haven't defined that yet, but we can talk about that in class. Basically how many streams are upstream of it. And then do we think that there's intermittent flow? And intermittent means that it flows seasonally. So does it have runoff basically in the springtime when snow's melting? Does it have ephemeral flow? And ephemeral means it flows only after rain. Or is it perennial flow? Is it flowing all year long? And then we'll include a map showing our watershed from StreamStats. So let's take a look at that real quick. Well, actually, we'll finish this. So include screenshots with captions and any embedded questions in this document. So if embedded questions, they're going to be, so take a screenshot here, you see that. Include screenshots, talk about this, write a few sentences on that. So look for these bold italics in the middle of the directions for your responses. At the end, you'll want to give a summary of what you did and then a reference list. So there might be some reason to reference a data source, a technical document, the manual, that sort of thing. So make sure you have a reference list, and I'll post a guidance document on how I want to see you do your references. Finally, for subsequent parts of the projects, I'll have you write up a component of your actual report for the final report, so you have that piece standing by, and we'll talk about for the next one. So in this section, you'll use this introductory paragraph for your final report. So anytime you do a hydrologic study, you want to give the background and kind of context of your watershed. And that's what this introductory paragraph about your watershed will do. So you do a little research on your watershed, and we can talk about it in class about what more specifics I might be looking for, or that types of things you can talk about. All right, so step one, we want to delineate our watershed. We'll go in to StreamStats, we'll put in that coordinate that I gave you, I assigned you, and you'll delineate your watershed. So you've had some experience with StreamStats at this point. So I've done that here for Canna Creek. And we'll do a couple things here. One, we want to, eventually we're going to download that basin, but let's continue. Well, yeah, let's go ahead and continue here. What we'll do is build a report on this watershed, and it'll give you a lot of information about kind of the land cover. There's a lot of GIS data that is behind StreamStats, and we can use this feature to give us some of the pertinent information that we want to talk about for our report. Okay, so I delineated the basin, I kind of clicked next on that thing, and we are going to look at scenarios. So I might as well just go ahead and do these things: peak flow, flood volume, low flow. Let's just get all that information. Basin characteristics, this is the one that's going to give us information about our basin. So let's go ahead and select all those as well. So we'll get a big old report here. I'll do continue, and then it's going to build my report. now that I've built my reports, I can StreamStats report, Canna Creek, might as well give a nice little title here. There's a little picture, that's great. And then I've got all these basin characteristics. And so I have put on Canvas a document that gives you a definition for all these codes here. So if you go to Canvas, under this assignment, week 1 project, right here, Colorado StreamStats support. If you download that, that'll give you a description of what all those codes are, as well as the background data associated with that. So if you cite any of that data, make sure you cite the documentation or the original data behind it. But I've got everything from the land cover right here. We've got the maximum elevation, mean annual precipitation. These are all important things, drainage area as well. These are all important things that you could show in your kind of overall description. Of course, we don't need to talk about everything, right? But you got the different land cover types in here as well, which is nice. So that's great. And we will, I think we can download that. We've got our StreamStat statistics. We're going to be doing this the hard way through HEC-HMS and modeling it. The statistical way, a lot of uncertainty, but it's going to give us a number to compare our models with. So I'm going to make sure we download all that information. And then a lot of information here. So we'll print it and save that as a PDF, and you can have that for later. Okay, now that we've got that report, save it, StreamStats report. Let's go look at HMS. Actually, now that we got that report, we need to download our watershed. So basin delineated, let's go back to that. We're going to download our basin as a shapefile. And there it is. And that's going to create this polygon that we can upload into HEC-HMS to visualize our watershed. Okay. So let's go ahead and the zip folder, we'll unzip it. I'll just call it watershed. Okay, so in this zip folder is all those flow statistics in a database file. And then we got a folder called layers. So that layer folder is going to contain a bunch of different files. And it contains flow path shapefile, a slope shapefile. The global watershed shapefile is the one that we're interested in. When I say shapefile, if you haven't taken GIS, a shapefile refers to several files, so 1, 2, 3, 4, that give us information about this watershed. So it's got to have the polygon information, it's going to have a projection, other stuff. So this is these 4 files create the shapefile. And that's what we can bring into HEC-HMS. So let's do that. And we will first do HMS, and we're going to do a new project here. We'll call it Canna. It's going to save it in my documents folder. Let's do US customary for units. We'll create it. And then we'll want to do a new basin model. So that's the first thing we'll do is a new basin model. And we can just call it basin 1. We can give it a name either way. So that's the first step, basin model. So it opens up a window here that's totally blank. We have no information. What we'll want to do is bring in some GIS data. So we'll bring in some streamlines that I have posted on Canvas, that GIS data folder, and we'll bring in our watershed. All right, so let's bring our watershed. We'll go to GIS coordinate system, WGS. Okay, so what I did is I went to my watershed file that I downloaded from StreamStats, and I looked for the .prj. So that means projection. It's going to have information on what coordinate system everything needs to be in. So I clicked on that, I did select, and it automatically loaded this. It's the WGS 84 projection system. So let's set it to that. That's good. Okay. And now that we set that projection system, that coordinate system, we can add our components. All right, so to add GIS data, we're going to go to Map Layers under View Map Layers. We're going to add, and it's already back in that folder there, so we're going to add our global watershed. And there it is. So that's our watershed. You might be able to change the colors. I don't actually know. Draw properties. Let's see, border, fill. I don't know. We'll just leave it at that. We'll make it a little transparent. Okay. Now we've got our watershed. If you want to make it a different color, that's great. The next step is we'll bring in that GIS data. So if you download HMS GIS Grand Valley zip drive, extract all. What this is going to have the flow lines for the whole county. So that's going to be helpful because it'll show us where we have streams. So let's go ahead and add that data. Go to View, Map Layers, Add. And I'm going to go back to my download folder, Grand Valley flow lines. So we're going to put that above. Hopefully we can move it up. It's going to take a while to draw this. It's a big file. It's for the whole county, so it's going to take a minute to load all those streamlines. So let's pause it and we'll bring it back. So after about 1 or 2 minutes, all those lines loaded. I moved them up. I just selected them and moved them up so they would draw on top of the watershed. All right, great. This is looking good. I'm liking it. We got our watershed. We got some flow lines. There's a lot of flow lines here. It's a pretty big watershed. What these just tell us is where we want to and the next part of this, we'll break this up into smaller subbasins, and this will give us some indication of where we do that. Now this data is only visual. It's not going to be any part of our model. Our model's going to be more kind of conceptual, but this is kind of the first step that I want you guys to do. Okay, to do something more complicated, we're going to do some more subbasins. So say I want to have a subbasin represent this upper area, and I can go back to StreamStats and delineate that subbasin and bring that shapefile in here so you can see it. So I'm going to put a subbasin for this area. I'm going to make some more subbasins. Let's do one for, let's see here. We'll do one for this kind of middle watershed right here, subbasin 2. And then I'm going to have a subbasin down here to get everything else in between. So let's do that. And we'll just put it down here. Okay. So actually I'm going to move these because the subbasin doesn't need to be on the stream. It doesn't have to really be anywhere. It doesn't actually matter. We'll just put it up in that general region so I kind of keep track of where it is. Okay. So I've got these 3 subbasins. They're not really connected to anything. So what we need to do is we'll create a junction. And we need a junction anytime a subbasin connects to something else. All right, so we'll put a junction up here for this upper watershed part. I'll put a junction, so that junction is going to have a reach that goes down and meets this subbasin. And I'm going to say that this subbasin starts right here, so I'll put a junction right there. So you can think of the junctions as the outlet points of your sub-watersheds. And then we'll put a junction, we'll have a reach that goes down to this outlet junction right here. Okay. Now I've got my junctions. Let's add our reaches. So here's a tricky thing. Reaches only connect junctions to junctions. they don't connect subbasins to each other. Subbasins are basically the area of the watershed that drain water to an outlet point, which is the junction, and then we use a reach to move water from one junction to the next. Okay, so junction 1 to junction 2, that's going to be reach 1, and then junction 2 to junction 3 at our outlet, that'll be reach 2. Now, the way to connect these subbasins to the junction is we'll go to our arrow tool. I'll click on this, and you can say connect downstream, and then I just click, and then I get this little line here. So you see this little black line now, and that'll follow. I can move this wherever I want. Now I'm connected to that junction. So I've got this subbasin, which represents this upper area, connected to that junction. This junction will make sure that it is connected to reach 1. I have to go back and assign that. And then reach 1 downstream, it's connected to junction 2. Click on junction 2 downstream, it's connected to reach 2. And then reach 2 downstream is connected to junction 3, our outlet. All right, I'll connect these other subbasins. So this subbasin kind of represents this middle area of the watershed. And I'm going to right click on that, connect to downstream, and then boom, now I'm connected to junction 2. And then finally, this gets kind of everything else that we missed in the lowermost portion of the area. So I clicked on that subbasin. I could either go here downstream and select junction 3, and it should be connected, or we just do this connect downstream tool and then click on it. All right, so now I've got my subbasin 3. So what I have now is, I'm going to change the color here so we can actually see that stuff a little bit better. Draw properties, let's make it a nice, so many good options. Let's do green. That's going to be a little, let's do, I'm going to make it a different color just so we can see all the junctions and reaches, etc. And hopefully not crash HEC-HMS. Okay, now hopefully you can see this a little bit better. Got a subbasin. Remember, I right-clicked on it. I said add connection or assign connection, and then that gave me a cursor that allowed me to click on this junction. So subbasin's collected to the junction. The junction serves as our watershed outlet point. That junction then takes all that water, dumps it into this reach, and funnels that water down to the next watershed outlet, or junction 2. And so all that water coming out of this subbasin will meet the water or the runoff coming out of this subbasin, go into this next reach, and then subbasin 3 will create its own kind of runoff characteristics, and then everything will meet down here at the outlet. So we'll talk about how to put information in and all these specific junctions. Now that I've split this up, I need to go back and correct the drainage areas. So say the upstream drainage area is 30 square miles. I don't actually know that. Subbasin 2, we'll say that's 50 square miles. And then subbasin 3, we got to get up to 100, so that's going to be 23 square miles, 103 square miles. The last thing I want to do is I want to resort elements hydrologically. All right, so I just right-clicked on basin. I did that. And so what it does is it starts with the upstreammost one, subbasin 1, goes to junction 1, reach 1, subbasin 2, reach 2, subbasin 3, and then finally our outlet, junction 3. And you can even rename that if you want to. We can call that outlet. So now I reordered everything, and it's going to work its way downstream in this contents thing. So go ahead and save your project, and then that's what we're doing for today for this first part.